Okay, so this is lesson 3. I can describe the connection between a statement and function notation and the graph of a function. So last time in class, in lesson 2, we talked about function notation. So we took a function that looks like this. This is function notation in its most basic form. So when we're looking at this, this is your basic function notation. When I point at the letter that's in front of the function notation, what does that tell me?
Input. Wait, no, that's the name of it, right?
That's the name of the function, okay? So if I had another function over here, g of x, the name of this one would be g. So the name of this particular function is f. Now, when we're talking about whatever value comes on the inside of the parentheses, it will always and forever be the what?
Input.
It will always be the input. Okay, the number inside of the parentheses when we're looking at function notation is always the input or the x value. Okay, so when we break down and look at the variables that we're talking about, whether it be distance or time or whatever, it's important that we know which one's the input and which one's the output, because the input's going to be the one that goes inside of the parentheses. Okay, so if we take all of this function and we were to set it equal to something, whatever it set equal to would tell me the what? The output or the y value. Okay, so that is what we talked about in lesson 2. So now we're going to take that understanding of reading function notation, and we're going to be looking at the graphs of those functions. All right, then we're going to use function notation to represent a relationship between two quantities in a situation, which is the graph of the function. And then we're going to take a statement in function notation and actually graph it ourselves. Okay, so a lot going on in this lesson, but I think you will pick it up pretty easily. Okay, so 3.1, we are observing a drone. It says, here is a graph that represents function f. So what's the name of this function? F. Okay, the name of this function is f. So anytime when we're looking at these function notations and you see an f, that is going to be talking about this drone situation. All right, Kobe, did you get that written down? All right.
Frisbee, I found out something too, but this says this is not a microwave safe container.
Good to know. All right, so function f gives the height of the drone in meters, t seconds after it leaves the ground. So our two variables that we're working with are height and seconds after it leaves the ground. So between those two, height and time, which one of those will be our input? The seconds. Anytime time is one of our variables, remember we talked about that's going to be our input. So the seconds after it leaves the ground will be the input. And that means that height will be our what? If seconds is our input, then height will be the output. All right, so now we have all the things we need in order to have it in function notation. So once again, it's so important that we know which one's our input, because the input always goes inside the what? The parentheses of function notation. So here is our situation right here. They've already graphed it for us. So as you can see, our input or our x is time down here on our graph. And our output is height, the y value. So it tells us decide which function value is greater. So this little line is representing the drone going up in the air. So it leaves the ground, the time starts. So what's happening after 2 seconds? It's increasing, it's going up. So just imagine the drone just going straight up into the air. All right, and then what's happening between this time and the 5 seconds? It's not flying horizontally. What's the height doing?
Staying the same.
It's staying the same. It's just hovering up there. It's not moving around. All right, and then what happens after 5 seconds?
It decreases.
It's just coming back down. So don't read this graph as saying that the drone's moving in this formation. This is saying this is the time that's passing. So as the time passes, it's going up in the air and then it stops and then it just comes straight back down. All right, so decide which function is greater. So we're gonna be taking function notation and looking at its graph. Okay, so the first one we have f, which tells us we're looking at this graph. And then this 0, what is this 0 telling us? Is it telling us the seconds or is it telling us the height? It's telling us the seconds because it's inside the parentheses, right?
Yeah.
Okay, so we're looking at 0 seconds. So how high was the drone in 0 seconds? It was at 0. It was still on the ground. All right, and now we're wanting to look at it when f is 4, when it's f of 4. So is that the height or the seconds?
Second.
It's still the second, so I'm going to go to 4 seconds, and I'm going to go to where my function's at, which is up there. So which one of these two are greater, f of 0 or f of 4? F of 4. All right, if y'all have y'all's Chromebooks out, y'all don't need them, so y'all can just shut those. Y'all don't need those right now. All right, now we have 2, 3, and 4. I want you to do those on your own, and then we will talk about them together. All right, I'll give you about a minute and a half to finish those next 3. All right, tell me which one is greater.
You didn't say it. Ready, go.
Ready, go!
Wait, what if they're the same? Is that the same?
Then is it greater or less than? Neither, so it would be,
I'll circle them.
okay.
You have like a really.
All right, let's look at it. So number 2, it says f of 2. So that's going to be at 2 seconds. So I'm going to go up where my function is at 2 seconds. It's right there. All right, then I'm going to go after 5 seconds. I'm going to go to 5 and I'm going to go up to where it is at 5 seconds. So what do you notice about those 2 points?
They're the same.
They're the same. They are equal.
F of 5,
Mhm.
you're saying those are equal?
Yes, because they're on the
They're
line.
the same line.
It doesn't matter what the number is, if that's greater or not, it's on the graph.
Yeah, because you have to go based on the graph.
You have that, wait, he's not, that's like at F of 6, right?
No, f of 6, it would be right here.
I'm so confused now, I'm lost.
So like if they're on the same line on the Y,
Look.
it's the same. So they'd be equal to.
There's 5 right there.
I know what I'm doing, and what you said didn't make sense.
F of
They were
2
both on the Y.
They're both
is
up.
right there. Look, f of 6 is going to be right here.
They're both like on the line together. Right.
I didn't know you were guys.
I mean, I know how to do it. It's because they're both on that top line.
They're both at the same, they all have the same output, so they're equal. All right, now we have f of 3. Okay, so that's going to be up here on this horizontal line up there. And then we have f of 7, which is all the way down here. So we have 3 up here, we have 7 down here. Which one's greater? F of 3 is greater. Okay, so it's not based on these numbers on the inside of it. That just tells you the input. You have to go and find the output of the height and then compare which is greater. All right, this last one may have tricked some of y'all just because it's written a little bit differently because they didn't give us a number. They gave us variables and a little expression here. So if they didn't give us a time to use, then we have to come up with a time ourselves. So we know that T is the amount of seconds that have passed. Okay. So someone give me that something on this table that we can use for seconds, just any amount of seconds. 2. Okay. So I'm going to make that F of 2.
Then can we make the other one because we've used like 2, 3, 4,
They
5?
both have to be two.
Yes. Okay. Just let me explain it. All right. So we have F of 2. So I'm going to go up here where I had 2 and it's right there.
So what do you call that? Because they can be greater and
I wanted to use 1.
Okay.
lesser, so.
Yep. You're on the right track. Give me 1 second. All right. So if that's 2, then if that T is 2, then this T also has to be 2. All right. So that's going to be F of 2 plus 1, which is what?
3.
Which is 3. So F of 3 is going to be this point right here. Is either one of those greater? No, they're equal to. But what if I would have chose a different number for T? What if I would have chose 0?
It could have been different.
What if I would have done F of 0?
Then the plus one would have been.
And then this would have been F of 0 plus 1. So 0 would have been here, 1 would have been here. Which one would have been greater? This one, right? So it could have been different depending on what we chose for T, right?
Yeah, and Mr. Colby was trying to come in.
Good. So it depends on what T equals. Okay, you can't say F of T is always greater, F of T plus 1 is always greater because it's going to depend on what you make T equal. So write that down. So write that down.
Can I put equal to because put the 2 and then write that?
You can just write this. Depends on what T equals. Did you get that written down? Just write it down. Don't make up excuses. I'm literally telling y'all what to write down. So everyone should be writing it. Okay, so that is taking things in function notation and just comparing them back to their graphs. Okay, so we're going to practice a little bit more. So this is, again, just the beginning of actually using function notation. We've only just kind of talked about what function notation is. We're still going to explore kind of how to interpret all this stuff. So don't stress yet. This next one is smartphones. Okay, so this function is named what? P. So anytime you see this P represented anywhere, we're talking about this smartphone situation.
Yep.
So the variables we're working with are the number of people in millions, okay, and the years after the year 2000. Okay, so we have these two variables here. We have number of people and we have years after 2000. So between those two, which one's going to be my input? Years, because that represents time, which we know is usually going to be our input. Okay, so if the years after the year 2000 is going to be my input, then what will my output be? We'll look at it in just a second. The number of people will be the output.
Smart said it, I'm gonna be good.
Okay, so now we have everything we need to know in order to understand the function notation. You need the name, you need the input, you need the output. All right, so number 1, it says, what does each equation tell us about the smartphone ownership? So first things first, we start with the name. You just read it left to right. So the name, it's P. So we're talking about the phones. Okay, now we know that this number is the input because it's on the inside of the parentheses. So what is the input telling us about in this problem? The years after the year 2000. So how many years after 2000 is it? So what year is it? 2017. Okay, so we're looking at the year 2017. Okay, so that means what all of it said equal to is my what? My output, which is the number of people in millions. So how many people own smartphones in 2017? 2,320 million. Okay, so let's write that in a sentence. So in
That's a lot of people.
2017, which was just 4 years ago, there were 2,320 million people with smartphones, which is 2.32 billion.
How did you know it was million?
Because they said it was in millions.
Oh.
I was so special, I was one of those 2 million.
Well,
2,000 million people.
Crazy, I didn't even know you in 2017, that's crazy.
I
didn't have.
You know, anybody.
You live in Alaska.
Okay, let's look at the next one and see if y'all can break it down. Hey, wait until I ask specific questions before you start telling me about it, because some of you may already know, but just wait till I ask the questions. All right, first things first, it's P. So we're talking about the smartphones. Next, this number inside of the parentheses tells me the what? The input. What's my input talking about in this problem?
Years after 2000.
Years after 2000. Okay, now wait. This time I have -10 as my input. So someone raise your hand and tell me what that could mean. Lake,
It means that it could be 1990.
it would be 1990. How did Lake know it was 1990? Kobe, he went backwards from 2000. Okay, so it's the 10 years before 2000. So we can go ahead and write that down. In 1990. All right, now what everything is set equal to tells me the output. What's my output talking about in this situation?
Zero smartphones.
The number of people who own smartphones. So, Luke, how many people own smartphones?
Zero.
Good. There are
Do better.
0 people with smartphones. Now let's think about it. 1990 was 31 years ago. Okay, so why were there 0 people with smartphones then?
Because they didn't have these.
They weren't invented yet. Okay, good.
That's what they want.
All right, so y'all are now taking that random combination of numbers in that equation, and you're applying it to real world. Okay, good. Now, I want y'all to remember these 2 function notations because we're going to look at them again here in a second.
Would 0 million people.
All right. Next, number 2. Now we're going to take these situations that are already in a sentence form and we are going to write it in function notation. So in order to write it in function notation, you need 3 things. What are those 3 things?
Input, output.
The input, the output, and the name. Okay, so we can go ahead and write the name. What's the name of this function? P. Okay, so we can go ahead and start there. Okay, now we need the input and the output. What's my input talking about for this situation? The year. So what year are we looking at? 2010. So there's the input. So if I'm writing that in function notation, I have to put it inside the parentheses. So now, are we going to put 2010 inside this parentheses? No. What do we have to, how do we have to write it? We just have to write it as 10 because why?
It's already so many years after.
It's the years after 2000. So we just have to put 10. All right. And then we set that equal to what? The number of people in millions. So how many people in million, how many people own smartphones? 200 and 96,600,000.
Like, that's actually right.
Okay, now, listen, if we were to write that whole number down, if we were to write the 296,600,000, then if we were explaining that, our function notation is in millions, so that would read 296,600,000 million. So that's not right. So what would I have to, how would I have to write it?
296.
Did you have a question or you were telling me? Okay, so 1 second. So we would write it as 296.6, which would be 296.6
So,
million
the
people.
one in 2017 would actually be like above a billion. It's like 2 billion, because it was,
Yeah, it was, that's what I said. I said it's 2.32 billion people. So yes, good. What was your question?
what's the output?
When you have that phrase is a function of, the output comes first in that phrase, because the phrase is a function of means depends on. So you're saying the output depends on whatever the input is. But when you're writing in function notation, the input comes technically first, but it's just whatever's in the parentheses. Good question. Okay, next. We are doing it in function notation again, so we have to start with the name. What's the name of this function? P. All right, then we have to do our input inside of the parentheses. What would my input be? Raise your hand. Jamarius. 15. Someone explain to me how Jamarius knew that the input would be 15. Ava?
Because 15 years after.
It's 15, the year is 2015, which is 15 years after 2000. All right, now, they made the output a little bit more complicated for us, so we do have to think a little bit. What do y'all notice about how they told us how many people are there?
They put billion.
They put it in billions, but we have to have ours in millions. So the difference between a billion and a million is 3 decimal places. So all you have to do is take this decimal and move it back 3 places. So how many millions of people owned a smartphone?
186.
1,860. 1,860 million, which is 1.86 billion people.
Why don't they just?
I think that's the population.
1,860.
Like you speak of this one.
Because they had to make us think. That has, the only reason I know it so well now is because I taught it 3 times yesterday. But that still confuses me, so whatever. All right, next question. Oh wait, before we go, I want you to also remember these 2 function notations that we just came up with. We're going to come back to those as well as the other 2 here in a minute. All right. Next question kind of takes us away a little bit, and then we're going to come back to the number 1 and number 2. It says, May is curious about the value of t in this function right here. Okay, first thing I notice is that the name of it is still P. So are we still talking about the smartphones?
Yeah.
Yes, okay. So it says, what would the value of T tell May about this situation? Well, what do we know that the T will tell us? The year since 2000. So T will tell May the years since 2000. Okay, now I want you to really think about this on number 4. I want you to think back to those 4 function notations that we just used.
What is that?
Think
What's under tell?
May, that's her name.
I think it's
M-A-I.
tell. I'm not,
M-A-I, sorry.
sorry. I'm not.
You're good.
Okay. Whenever we're talking about like years,
Mhm.
why do they not put anything after the first digit? If 5,000.
This isn't years.
Well, I mean, we're like, we write out 2021. There's nothing there, but it's still 2000.
Wait, say it one more
He's
time.
saying like, in it, when we write out a year, we don't put a point of comma,
Oh, I don't know.
right?
Is that what you're saying?
Would it? I'm kind of confused now.
I don't know what you're saying.
We just write,
It's 2000.
yeah, we just write numbers.
Weird. Because I mean, we learned that from that.
Yeah, that's true. I don't know. The other day, someone, and we say like 2021, so we say it like there should be a comma
Mhm.
in the middle.
2020.
Remember McDonald's always forgets the decimal point when they say T is $1.
All right. Now, B says is 4. All right, listen, y'all need to really think before you just say an answer. It says, because we got to think of our timeline of the phones and how many people had phones. Okay, so it says is 4 a possible value of T here? So we're plugging it into this function. So what would 4 mean in this function notation?
4 years after 2000.
4 years after 2000, so it'd be
2000.
2004. So what this function notation would say is that in 2004, there were 1,000 million phones or 1 billion phones. Okay, now thinking back to our other function notations, does that line up?
No,
Wait, yeah.
no.
Well, I wouldn't think it would, because at 15 years, or at 10 years, there's only.
Yep, you're right.
There's only that.
Okay, so listen, Lainey explained it perfectly, and that's exactly which the one I was going to use. So in 2004, it's saying there are 1 billion people with phones. And then in 2010, which is 6 years later,
4?
Uh-huh. 2004, there were 1 billion phones. Okay, and then in 2010, there were only 296 million phones. So there was 800 million less phones in 2010. Does that make sense that there's less phones
No.
later on? No, because what do we know about technology?
It advances.
It just advances. More and more people will probably have it.
Why are we learning all this stuff if robots are gonna take over the world?
So the answer is 4 possible value here. No, because in 2004, there can't be more phones than in 2010. Now, had the output been different, then yeah, maybe 4 could have possibly worked. But for that particular for 1 billion phones, it just doesn't make sense in our timeline. And we're going to look at that here in a second when we graph it. And you'll see it graphically and why that doesn't possibly make sense. All right, so that brings us to number 4. Y'all remember those 4 functions that I told you we were gonna use again? Well, this is where we're gonna use them. We're gonna use the information you have so far to sketch a graph of the function. All right, so starting back with number 1, our function was P of 17 equals 2,320. Y'all rewrite these functions just so you know where they're coming from. All right, then you had P of negative 10 equals 0. You had P of 10 equals 296.6. And P of 15 equals 1,860. All right, so now we're going to learn how to graph function notations. Yeah, super fun. Okay, so when we are graphing on a coordinate plane, we only need 2 things, right? What do we need? An X and a Y. So we're graphing these function notations. So from those, we need to find an X and we need to find a Y. Where do we know our X's are in function notation?
Input.
The input, okay? So all of these values inside of my parentheses are my X values. Okay, so that means that everything they're set equal to is my what? The Y values. My orange pens right now.
Wait, we do the same thing with phone numbers too, don't we?
What?
We put dashes for phone numbers.
Well, I mean, we put dashes, right? Why would we do that?
Because they're not, you don't read them like you read numbers.
870,000.
Who came up with that?
You grab them.
I can imagine.
All right, here we go. I'm gonna graph this first one with you and you're gonna do the next three on your own, so pay attention. So first one, we start with our input or our X value. So we're talking about the year since 2000. So on this first one, how many years was it since 2000? 17. So I'm gonna look on my X axis and I'm gonna go to 17, which is right here between the 16 and 18. All right, and my output is 2,320, which is in the millions, right? Okay, so I'm gonna go up to where that would be. So I'm somewhere in between the 2,000 and the 4,000. I know right in between those would be 2,200. Okay, so I know it's gonna be just somewhere above that line. Doesn't have to be perfect, but I know it's gonna be somewhere like right there. Because this line is 2,200, so it just has to be above that line, but below the 2,400. Okay, and that's how you graph it, just like you would on a regular coordinate plane. You just have to know what to look for in the function notation. All right, so I want y'all to do the next three on your own. I'm gonna give you about a minute and a half to do it, and then we will talk about it. Ready, go.
We use flat the points.
Uh-huh.
Oh, that we only found online, so no.
Yeah, just plot the points right now.
Well, I was trying like 20 of them.
Yeah.
All right, whenever you're finished, you can look up here at mine and check what you got.
Boom.
They're like,
I was
just like a
super.
inch or so.
Yeah, you're good. Just because it's not, I mean, you're just having to kind of guess where some of those spots are.
Okay. Wait.
Except that 10 and
That's a lot off.
That's all.
Huh?
Except that 10 and 0.
Like,
As long as you have the right input, if you're kind of off on the output, I'm not gonna count wrong.
maybe like 100 of them.
All right, so your graph should look something like this. Now, because it's a function, we do have to connect those points. So just based on the information we have, which was just those 4 inputs and outputs, we're gonna connect it like this. So we have 1990 down here. So we've got to connect it to 2010. So it looks like, I'm gonna assume it was just a gradual increase of cell phones. Okay. And then in 2010, what happens? They just jet up. Okay, and then from 2015, they increase again, and I'm just gonna assume they just continue to increase from there
We should come back to your class and finish it. The next one.
every year
Well, I mean, there's only got a couple
until
years.
2022. All right, so now I can check, is this a function? Yes, it passes my vertical line test. Okay, now, because we only had those 4 input and outputs, there could be some discrepancies, you know, in between here and there, you know, like we don't have every single year, so it's not gonna be exactly perfect. But earlier when we were talking about that one with May, and we were looking at 2004, it was saying that in 2004, which is right here, we would have 1,000 million phones, which would have been right there. Okay, so it doesn't make sense that that's true, because that would mean that in 2004 it just shot up, and then for some reason people just quit buying phones, literally got rid of them, and then they all increased again. So that doesn't make sense, right? So that's why May's little function notation wasn't true earlier. Okay. Yeah, so that's the smartphone. So we're going to do one more activity
Boiling water.
and then we'll take a break. Okay, so this one's boiling water. So I want y'all to imagine yourselves in a kitchen, and you put a pot of water on the stove and turned it on. Got it? Okay, so we have function W. What's the name of this function? W. So anytime you see this W represented, it's talking about this pot of water on the stove. All right, so it gives the temperature in degrees Fahrenheit of a pot of water on a stove T minutes after the stove is turned on. So we've got temperature and we've got minutes. Lake,
I think, I know what input and output is.
what is my input and output, Lake?
Your input is your time.
My input is my time. So I know that anytime I look at my function and I see the number inside the parentheses, what's it gonna tell me?
Your time.
The minutes after the stove is turned on, which is my time. Good.
And then your output is your temperature.
And so then whatever it's all set equal to is gonna tell me my temperature
Fahrenheit, degrees Fahrenheit.
in degrees Fahrenheit. Okay, I'm gonna do this first one with you, and look, you are gonna do B through F on your own. Okay, so it says take turns with your partner. Yes, you'll get to talk these out with your partner. And we can all kind of be each other's partner if we need to. Take turns with your partner to explain the meaning of each statement in this situation. When it's your partner's turn, listen carefully to their interpretation. If you disagree, discuss your thinking and work to reach an agreement. Okay. So let's look at this first one. We have W, which means we're talking about the pot of water on the stove. What does this number inside of my parentheses tell me? 0 minutes after the stove is turned on. So we haven't turned on the stove yet.
It's just room temperature.
Okay, so what it's all set equal to tells me the what? The temp. All right, so someone explain this function notation to me in a sentence form.
After 0
After 0 minutes, write this down. After 0 minutes,
The pot of water is 70.
the water is 72 degrees Fahrenheit.
Also known as perfect breaking.
All right, you don't have to make them super wordy, just as long as you hit all of the points on them. Okay, now some of them they're not all going to be perfectly like that. Okay, there's really only one more that's like that, which is C. The other ones here, you have some inequalities. Remember, inequalities are these greater than, that's a greater than sign. That's a greater than sign, and this last one is less than. Okay, so before y'all panic, because it's a little different, I want you to just talk it out. Okay, well, we'll get to it. It's okay to struggle just a little bit. Okay, now I'm gonna give y'all about 5 minutes to talk through these and write them out. Okay, I want you to work together, talk it out. So catch.
We have to write each one out.
Correct.
Wait, with the partner or just with your group of
The whole.
You can use a group if you want or whatever you need to do. All right, ready, go. All right, so let's look at B. Someone explain to me what B means. Ava.
The water at 5 minutes is greater than the water at 2 minutes.
The water, I'm gonna say the water temp at 5 minutes is greater, hotter than temp at 2 minutes, which we know makes sense. Now, if you don't have it worded exactly like that, if you have something along those lines, you don't have to change your answer. But that makes sense, because if we turn the stove on, obviously, if it's on there for 5 minutes compared to 2, it's gonna be hotter because it's on there longer. All right. What about C,
Hey,
Jamarius?
After 10 minutes, the water is 212 degrees Fahrenheit.
After 10 minutes,
It doesn't really make sense. Either.
the water is 212 degrees Fahrenheit. Now, that means it's boiling. Okay, that's the boiling point of water is 212 degrees Fahrenheit. Okay, what does D mean? Ava?
The water is equal at 12 minutes.
The water temp is the same or equal at 10 minutes. Oops, I meant to write 12 minutes first. And 12 minutes, same, yeah, that's fine. Okay, so how is it gonna stay the same? Why is it not increasing anymore? What do you think happened?
Boiling point.
Topped off.
It's at boiling point, but
It could be like a little bit colder,
they could what?
or.
Yeah, we got
the-
turned off.
Huh?
Oven got turned off.
The stove probably got turned off, okay? Now the water's just at the same temp. Okay, now, E. What does E mean? Kobe,
But at 15 minutes, it's the same thing as it would be.
No, no.
it's not the same.
Vice versa.
I mean, 15 minutes is longer.
Good. At 15 minutes, the water is hotter than at 30 minutes. Okay, so earlier we said the longer it's on the stove, it's gonna be hotter. So why is it now hotter after 15 minutes than it is after 30 minutes? We already said they probably turned the stove off. So what's happening to the temperature of that pot of water? It's decreasing, which makes sense because we're not gonna keep a pot boiling for hours. Or, yeah, 30 minutes. Okay, last one. Explain to me the last one, Ava.
The water is less at 0 minutes than 30.
The water temp is less than or cooler than the temp at 30 minutes.
Wait, is this the only thing we're gonna do is in the summer,
Correct.
and then we're done?
We're gonna do the goals in lesson 4. That's it.
Can we just go ahead and get that finished and have the rest of the process?
Sure.
Y'all wanna do that?
You do what?
Just do the rest.
Are you saying I do the break time?
What time is it now? What time is it? 9. If we do that, we'll have plenty of time. We'll have more than 10 minutes.
What are we doing?
We're gonna finish this problem. Here we go. So we're gonna take all of these. It says if all the statements in the previous question represent the situation, we're going to sketch a possible graph of the function we just talked about. Be prepared to show where each statement can be seen on your graph. Okay, now this part is gonna be like, it's gonna challenge your brain a little bit, which is an okay thing. So when I'm graphing function notations, I like to start with the points that have an input and have an exact output, like A and C. I like to start with those because those are exact points on my graph that I know exactly where the point will go, right? Okay, so let's look at A. What's my input? 0. Okay, so I'm going to go to 0 on my x-axis. And where is my output going to be? 72. Okay, so I'm going to go up. I know this line right in between 50 and 100 is going to be 75. So it's just going to be right below that line. All right, so there's that first point graphed. So I'm going to go up here and done. I'm so sad. My orange is running out. Okay, next we have C. What's my input? 10. What's my output? 212. Okay, so I'm going to go up here to 200 And then 212 is just gonna be halfway in between 200 and that middle line. Because 12 is halfway between, it's half 25. All right, now, there's one other one that I can do with that information because this D, it tells us that the output of W10 is the same as the output of W12, right?
So then it's just after 12 be a straight line.
So it's just gonna be like right here.
Wait, how do you know
Because right here, it tells us that when we go to our input of 12,
Oh, okay.
our input of 12 is the same,
Okay.
not the input.
It's just the same.
These are equal. So if W10 equals 212, then W12 also equals 212 because those are the same thing.
Whoa.
So W10 right here equals is the temperature is 212 at,
that? But it says it-
I know, but they're equal
Yeah.
to what W10 equals.
So how did you do the inequalities if one is not equal to another? Because we know what 10 is because of the one before.
Okay, so for the inequalities, that's why I wanted to wait for those to be last. So for the inequalities, we don't know exactly where they are, okay? Because it doesn't give us an output. So we just have to make sure that we make all of those statements true. Okay, since we don't know the exact points of them, we just have to make sure they're true when we do our graph.
So we just gotta go in between.
So for example,
No.
right here since we know from 0, our input of 0 and our input of 10, I'm just gonna connect those 2 points.
Oh, you're gonna use the.
Yeah.
On something to do. Wait, but. Look at.
Just trust me, just trust me.
I'm trusting you, but I don't.
All right, I'm just connecting those 2 points. Just those 2 right now.
Okay, I won't connect that.
I'm looking at this B one right here. I'm gonna explain that one. Okay, so this is saying that the output after 5 minutes is greater than the output after 2 minutes. So let's see if that's true based on that line we just drew. I'm gonna go to 5 minutes. I'm gonna go and I'm gonna graph it on my line. And then I'm gonna go to 2 minutes and I'm gonna graph it on my line. Now look, is the output after 5 minutes greater than the output after 2 minutes?
Yeah.
Yes. Okay, so did we make it true? We made it true. Good. Okay, so we're done with B.
Oh, okay, so that makes sense. We just kind of go off of the line we've already made.
Correct. Okay, so I'm gonna just assume once again that those 2 are just gonna connect to each other. There's no function notation about what happens at 11. So we can just assume that's what happens. We don't know for sure, but we can just assume it does. Next, it says the output at 15 minutes is greater than the output at 30 minutes. So we just have to make that be true on our graph. Do we know what the output is at 15 minutes?
You don't have any lines to follow on.
We don't, so we just have to make it true on our graph. So what do we want the temperature to be at 15 minutes?
200.
It can't be 7.
I'm just gonna assume it's the same. You keep it boiling for 15 minutes.
We just want to keep it boiling, so we just want to continue that line to there.
Cause I'm gonna assume that the oven will turn off at 15.
Okay,
So,
so we're gonna continue it.
I'm at 10, yeah.
Okay. So it's just boiling for 5 minutes. That's what our graph is saying, right?
Yeah.
Okay, that makes sense. We can keep it boiling for 5 minutes. Okay, but then we get to 30 minutes. It just has to be less than this point,
But it also has to be above
but it also has to be above
72.
the point at 0, because it says that right here. Okay, so what do we want the temperature to be at 30 minutes?
109. 2000.
I'm just gonna make it 100 because it's less than this point, but it's greater than this point. So did we make both statements true?
Yeah.
Good, okay, so now we just have to connect these two.
And then we just swap the.
Boom.
We're done.
So this function notation says we turned on the stove. It got hot. It boiled for 5 minutes. We turned it off and the temperature dropped. Is that true? Does that make sense? Is it a function? It is. It passes our
Article on there.
vertical line test. All right.
We're done now?
We're on our lesson summary. Okay, it's at the bottom of your page, page 149. It says, what does this statement, P3 equals 12, what does it mean? Can we know what that function notation means if they just give us the function notation?
We know
Nope.
that.
All we know is the input and output. What's my input? What's my output? What's the name of the function? That's all we know because they didn't give us any variables or anything. That's all we can say with it. And it says, that's exactly what this little line says. On its own, it tells us the name P with 3 as its input and 12 of it as its output. But on that last sentence, it says, if we know what the quantities are for the input and output, we can learn much more about the situation that the function represents. So then it gives us these 2 bullet points and it kind of just gives a couple examples of what it could represent. So the first one is an example. It says, okay, we want P to represent the perimeter. Okay, so that's the name. All right, and it's going to be for a square. So it's important that it's a square because what do we know about squares? All the side lengths are the same. The side length is X, and both are in inches. So it says that when we're talking about that, 3 is going to represent the side lengths, and 12 would be the perimeter, which is what that last thing says. All right, going down to the next bullet, we could say, all right, we want function P to give us the number of blog subscribers in thousands, and we want our X to be, or our input to be months after a blogger started publishing online. All right, so we have P of 3 equals 12. So if X represents the months, how many months have gone by? 3, and how many subscribers do they have? 12,000. Pretty good after 3 months. They're doing something right. All right. Good job. It says, it is important to pay attention to the units of measurement when analyzing a function. Otherwise, for that last one, we could have mistaken after 3 months, she only has 12 subscribers. Okay, because if that's what we think about it, then we're going to want to change a lot of things if we didn't understand that it's actually 12,000. All right, a graph of a function can likewise help us to interpret statements in function notation. Okay, it was really helpful when we had that graph of the smartphones to see why May's function notation didn't work, right? Okay, it was really helpful to see it that way. Function F gives the depth in inches of water. Okay, so we're looking at this graph here. We have function F. What's the name of it? F. All right, it gives the depth in inches of water in a tub as a function of, there's that little phrase, as a function of time. Now, when we have that little phrase, what is the variable in front always? The Y, the output. So the output here is the depth of the tub. All right, what's my input? The time in minutes since the tub started being drained. All right, so What does this decreasing part of our function represent?
The water being drained.
The water being drained. Okay, then what happened after 7 minutes?
It just stopped.
It stopped being drained. So what do we think happened in real world?
Plugged it up.
They probably plugged it back up. Okay, so that's what that function is talking about. So y'all are already taking these mathematical situations and these function notations and you're connecting them to a real world situation, which is really important. So it says each point on the graph has coordinates like this, where the first value is the input and the function of the function and the second value is the output, just like we normally would with graphs. Okay, and then those bullet points just break down that graph up there. Okay, but y'all didn't have any trouble reading the graphs of functions. All right, that's it for lesson 3.
Yay.